All right, cool. So yeah, when Lena asked me to give a talk, I just thought something that came to mind was a really fortuitous experience coming second place in an international predictive modeling hackathon. Happened to me 2 years ago, and yeah, it was just a series of very fortunate events meant that I ended up coming second and winning a bit of cash. But bigger picture, why do we do hackathons? So I'm going to sort of today go through the process and my experience of what I did to get that second placing. And at the end, I'm going to share the GitHub repo with the code and the data as well, if you like that. But why do we do hackathons and why are they a benefit? Um, in my experience freelancing, I've only really had two professional predictive modeling engagements. One was for a call center optimization, and the other one is predicting building industry insolvencies for a credit bureau. So they make up a very small portion of my income. The rest is mostly just business intelligence stuff that I do. But they offer some great benefits. And so like doing data pipeline management skills is one of the key aspects of it, because you got to, map it out from taking the input data to doing the submission file and all that's in between. If you have to make a report for these hackathons, ggplot and all that stuff, getting practice with that is very invaluable as well. And it's also healthy competition because you can sort of gauge how you might compare to other people. But bear in mind, you've got no way of knowing how much time they spent. And for myself, it was in February, like 2 years ago, and it was February, January, always a quiet time for freelancers, so I had lots of time. So, yeah, cool. So it's a simple, you can't see the header, a simple three-step process. You just enter the competitions, and then you do a little bit of stuff, and then you win. And then after you chase them for the cash, you eventually get some money. So I wish I could sell a course that could guarantee winning hackathons, but can't do that. It's not Kaggle, so it doesn't count. Okay. So this company, Crowd Analytics, is very niche competition platform. Nowhere near as popular as Kaggle, but they did put out some good competitions. And just luck would have it, the email came into my inbox one day, and I thought, oh, I'll give this a go at the right. Yeah, it's just hit me at the right time. All right. There was no official congratulatory post by the Crowd Analytics website, so I made my own. Uh, just on LinkedIn, and just sort of shows the emotional roller coaster of what I went through. Coincidentally, it was on the day when the Dalai Lama said something. Yeah, he sort of really embarrassed himself in a for the first time ever that I've ever seen him. Embarrassed himself by saying something quite weird in a conference, and I was massively cringe at that. But it's all right. Okay, so a quick plug is what the header says. I wonder if it's possible to get this to go up. Oh, did it go? Hi. Oh, Bonza. Thank you. Okay, cool. So a quick plug for my freelancing. So I do R to mostly do data wrangling and data engineering, Google Cloud Platform and Tableau deployments for mostly small businesses. I do Power BI as well if I get forced into it, which happens a lot. Okay, this is the competition. The data was provided by Tennis Australia. I've sort of hassled them to try to get the actual test data, but they haven't really come through with it yet. And you can still see this competition live on the website. You can't download the data anymore though, but it'll be available in the GitHub repo for anyone interested. The competition. So what is it? So we had a whole bunch of data and we had to predict where the serve would land. So for each rally, for a series of matches by the Australian Open, where would the server place the ball? Okay, so I sort of made this plot with ggplot, and that is the challenge. Okay. Oh, and feel free to yeah, feel free to ask questions and jump in if anything strikes you as we go. So there's the training file is one lump of matches, and then there are a second test file, and that's sort of individual rallies that slot in between the other rallies. Okay, and so they're your test rallies that you've got to predict for, and I think there's like 5,000 of them. Yeah. So if you look at here, it's a little very basic ggplot chart, but it's from match 480 onwards, which is where the test rallies start, and the red dots are actual test rallies. So going across there's the little dots, those lines are actually little dots, okay? And they represent individual rallies, and then the red dots are the test rallies. Okay, you get it. Okay, so the data. So the interesting thing about the data, and I'll show you a screenshot of the data frame in a second, or the tibble, depending upon. The key bits of information. The important thing that they stressed is that you're not to use future information when predicting the zone of where the serve lands. So we've got like set number, game number, point, court side, serve, receiver position X, a whole bunch of features about each rally that we knew up to the moment when the server hit the ball. And then in the rest of the columns, we've got things that happened after the serve. So whether the serve was in play or hit the net, and the outcome and the point winner and the zone, okay? So they really stipulated don't use the future information, but they provided it to you, okay? So this is just simply what the raw data provided to us looks like. All right. I might share these slides afterwards so you can look into them if you fancy it. Okay. So as I said, the test rallies are sprinkled within the training data's time frame. It's very easy to mistakenly use the outcome of the rally to predict the zone, but also info from future rallies to inform the current rally that you're predicting for. This sort of competition setup, of data setup, is rare because it's unpoliceable. The only way to assess whether a competitor made use of the leakage information is by assessing their code, which they said they were going to do for the top finalists. But if you made a submission, they were by accident, using the future information, there was no way to retract your submission. So you could have got a very good score and then been unable to retract that submission. Cool. So yeah, so for any given...
If you use like the whole data set, the whole training data set, for instance, to train a feature like aggressiveness of the player, which would be informed by all of the information you had available to them.
Yeah.
Like before and after that particular matching set, would that breach those rules as well?
You wouldn't be able to use the after data, but definitely you could make it a feature for the aggressiveness of the player using the historical information. Yeah.
And then there would be a feature which might, like, value would change over time.
Yes. Yeah.
Was there time slot as well? I mean, how far down? Still, because tiredness also affects your...
Yep. So no, there was no, it didn't show it for long enough, but no, there was no time for when the rally was occurring or date for when the matches happened. It was all just sequential matches extracted from a database.
What could you say, like basically a set of like one rally, and then basically when there's a fall or something, then the next rally, and then the next rally.
100% correct. Yeah.
You couldn't use. All right. So basically, you essentially had to be able to predict when the next rally started, where the first move, the serve, the ball would land, using the past data.
Yes. I think I understood.
Yes, so that's sort of a bootstrap, right?
Yeah.
So the very first match, you would be nothing.
Yes. Yeah. Yeah. Exactly. Yeah. Okay. And so obviously for these competitions, the first step is to build a cross validation, and what I refer to as a pseudo test rows. So I developed a set of criteria that would give me a bunch of pseudo test rows that looked like the actual test rows. And that's what I'd use to train my model and see if I had not to train, but to test my model and to validate that the model is working. Okay, so my criteria were this: they couldn't be a test row because there'd be no zone result, couldn't be a false serve because there'd be no zone result, I didn't want it to be straight after a test row, because I wanted to have features that looked back and saw what was the zone previously served into, stuff like that. And I didn't want to be in the first row because I remember there was some issue with the first row of data. So this is what we got on the left. These are all just ggplot charts that I pulled out of the report and had to submit. And I probably didn't spend enough time, making them schmick or even modifying the original ggplot theme or colors. But yeah, so the pseudo test points looking very similar to the actual test points.
Just asking, first, how do you get the test point in the training set? Is that if you stop data randomly with this flip screen?
Yes, so there was random aspects. Oh, sorry, what's that? There is random aspects to how I selected the pseudo test row. So I did set seed when I did it. It was using this sort of logic. It was just sort of, and then
you obviously had to exclude the test rows.
Yeah.
The test rows. Then you basically randomly chose. The question is, how did you figure out how close your data points were to the test? What it would qualify as a pseudo test?
Yeah, I can't remember exactly. I think it was like there had to be at least two rallies ahead of an actual test row.
Okay.
Yeah, something like that. And so there was sort of random selection. I didn't pick all available because there had to be some training left in there.
What is the actual training test ratio? Do you training set and test them?
Yeah, I can't remember off the top of my head, but I think it was maybe like 5,000 to 30,000, 5,000 tests to 30,000 actuals.
Okay.
Yeah, something like that. But the data is available on the GitHub repo. All right. So here's the plan. Okay. So we just try a whole bunch of different techniques. We try to get the validation score as good as possible. We make a submission. We're only allowed 5 submissions per day, and then we check if this is like a newer thing that I've sort of thought of, but like you check that your cross-validation scores, if they're getting better, you also want the leaderboard scores to be getting better, or else if there's a disconnect, then your cross-validation method is not reflecting the actual test data. Okay, and then you just keep repeating until you exhaust it. Okay, the different techniques is the real killer. Okay, there were also missing rallies, which made it even worse. And these were rallies that were taken out. They were neither in the training nor test file, and they were a holdout bunch of test data because the competition organizers wanted to take our code with the select top ranking people and run it again with unseen data. And so that was another step of how to determine the final winners.
Someone would have cheated using the test as part of the main data.
Yeah.
It could easily be found out.
Yeah, exactly right. Yeah. So there was public leaderboard, private leaderboard, and then holdout data set. And also the ability to run your code, which was in itself.
For example, let's say row 500 had the test set.
Yeah.
And you were only using the top, let's say, 200 rows. You couldn't use row 501 in your system because you can't use future data, right?
Yes. Yeah.
So basically, you learn that from 400, test it on the test set, and basically start from. Then what do? Do you exclude the test set and then you use it again?
I get what you're saying. So yeah. So.
Is that what you did?
Yeah.
You added it to the data and then ran your.
Yeah.
Whatever you did.
Good point. Yeah. So you aren't prohibited from using a test rally to inform a future prediction.
Oh, okay.
Yeah.
So
Cool.
you could basically, technically speaking, once you test it on that test row, add that test row to your data, continue on just before the next test.
Exactly. 100%. You got it. You don't have to only use the training, the isolated training data with no. That initial the earlier portion of the training data, which is only training, and there's no tests sprinkled in there. Yeah, exactly.
This is multi-variable time series analysis officer.
Yeah. Okay, cool. A competitive advantage. Okay, we had game scores of the server and receiver, but we didn't have in that data, if you were really quick to look at it, we didn't have how many games point sets each player had won in the match so far. Okay, so we didn't know, we weren't given how far in front or behind each player was. The function to determine this was actually a lot harder than I initially thought it was. Um, not only because the server and the receiver would swap, like in those columns after each game, so after each like 5 or 10 rallies that would swap, but because of the missing rallies as well, it was hard to you couldn't exactly track the score always. Yeah, so it sort of threw a spanner in the works sometimes. But I had the free time, and I worked out the function, or I got something close to working. And so I consider this my informational advantage. So I was motivated to invest my time more in this competition because I thought, oh, I've got this extra thing in my pocket that's going to help me. That maybe some other people have thought of, but it it's not that of a far reach, like your aggressive player feature. But the function was tricky enough that I thought, oh, I don't think many people are going to waste their time figuring it out. Um, cool. But before we get into interesting features, the simplest way to start is just like historical rates. Yeah, well, what percentage of all the history um, resulted in certain zones. And if you looked at the rally types, like the really big picture ways of describing the rallies, there's only so many categories, categorical variables and possible combinations. Okay. So if this is two little fantastic ggplots with the default theme, but these are all those different combinations of rallies, and the lollipop charts are the probability of each of the zones. Okay. So and you can see in very tiny writing the number of rallies that inform those rates. This is only using the training data, so not recycling historical information. And so you could use like those 4 features, or you could have just used 0 features. And this is sort of the chart that you get as you add in the features, how it improves your log loss. Okay, so we can see that serve is the big one that really improves the predictions, but serve plus court side and then serve plus receiver handedness, so you can sort of add that to get a really good starting point, basically. Going back to your sort of question before, you've then got the choice of not only how many categories you're going to use for the rates, but do you only use the pure training data, or do you use all the historical rallies for each test point? And so I used all the historical rallies for each test point. And that's sort of required to do parallelization in R. So that was a bit of fun figuring that out. And hearing my computer and hearing the fans whir up, it's always pretty cool. You're like, yeah, I'm doing cool stuff if my fans are spinning. And not yeah, so obviously you can use all the historical rallies of all the players, but you can also just niche it down to only the players involved or the server involved. So you've got all these different like simplistic guesses at the different zones, basically. The first thing, one of the important things to take away is that when you're making predictions using these rates, sometimes we got some really poor performing rallies where we'd predict with absolute certainty that it was going to be zone 2 and it was wrong. And so the performance metric was huge. Whereas if we just dialed it back a tiny bit and said we're 97% certain or 95% certain, instead of 36, it would be like 4.6. So the performance metric was much better. So it just pretty much said that sort of reviewing the pseudo test predictions and looking at why bad predictions are happening, and then using that information to change your process a bit to account for it. So I did a bit of that. Then I just made a whole bunch of features and did the XGBoost models dance, which is make features, tune hyperparameters, remove the unimportant features, retune the hyperparameters, and train on the full training data, make predictions, that sort of thing. I think I tried using only the training data, and then I also tried doing it for each test point, or maybe every 10 test points using all the historical. So that was just experimentation, just trying different things. These are some examples of features. I think like servers, the bottom right, servers total faults so far, servers total aces so far. Like some of these, this is just a few sample of the features, but some of them are more interesting than others. And yeah, some of them are sort of lagged features. And so this is pretty much when you make an XGBoost, you've got like all the different variables and then the cumulative amount of importance that you've covered by having so many variables. And when I see something like this without an obvious elbow, it just sort of says that, it's just sort of adding little bits and pieces and probably isn't really that reliable to me. I'm self-taught, so that's that's my conclusion. So I normally just cut it at 80% and just use what I hope are going to be the important features. Yeah. So in the
you could have done something like cumulative, where adding particular feature, how much cumulative improvement you get, and then you set a cutoff point for yourself that the improvement is say not more than 1-2%.
Yeah. So yeah, like doing it by a gradient when the gradient of the curve gets too low. Yeah. That makes sense. Yeah. Yeah. Unfortunately, many of my like the gravitas calculations, like how far in front or how behind, none of them ended up being important features, which was very disappointing. And the XGBoost model performed worse than the historical rates that I was doing. So I was very disappointed in XGBoost. I had actually assumed that it would perform better in all cases, but it didn't. So
feature engineering, you had to do a lot. If you wanted to work much better, you would have had to do a lot of feature engineering with combination of different sort of features and
yeah, but I thought if XGBoost contained the categories that were used in the simple rates, that it would have to be better. But it wasn't.
So intuition-wise, that's what you're thinking.
Yeah, and also what I because there's the random elements of XGBoost. Sometimes it's better to make 5 XGBoost predictions and average them, because XGBoost will give you with repeated training, it'll give you very different predictions. So now in my professional, luckily, after I did this, I learned a bit, and I went back to my old client came back to me and was like, oh, can we add some features to the building insolvency prediction model? Can we add some features? And I'm like, oh, I've got to sort of redo the entire code now. So luckily they let me do it.
You used you used DeepNet?
No, just XGBoost. Yeah.
Well, that is
Oh. XGBoost isn't a neural net.
That's why I see you that.
Anyway, so
I don't have I don't have knowledge of that.
Good. Anyway, so the XGBoost model performed worse, but blending it with the simple rates gave better predictions.
But I can see why XGBoost is your candidate.
I'm a simple man. Sorry.
It's the reputation of winning.
Yeah. So that's pretty much what I based my choice of model on. I just said, oh well, it seems to win. It was super popular. There are. So
the rates model.
Yeah.
okay, so the rates are sort of what I talked about before, was sort of like the categories to describe the rallies using the historical zone probabilities just of those like so it's not a model per se, but it's just the historical rate Is that?
Finally segment, like it's.
Yeah.
Series of 10.
Yeah.
And then.
Which you want to calculate.
Yeah, so it's pre-calculated. So there's no modeling involved. It's just R, summarize. Yeah, yeah.
Then which is sort of.
Yeah.
It's,
Yeah. 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 Yes.
It will change like every time you add.
Yeah, as you accumulate more values into it. Yeah. But so it's interesting that blending the historical rates with the XGBoost model ended up getting a better prediction both in my pseudo test and in the leaderboard. And I was made my own little like giving different weights to the predictions, like and trying a whole bunch of different things. And so in the process of doing that, got ended up, I think it was like in the end, it turned out to be the 15th, but as the deadline approached, it was like 7th or something. So I was feeling quite good. But I was definitely running out of the science. So when I could boost my cross-validation score, not necessarily on the public leaderboard. So I was sort of just got sick of it because I'm like, oh, this should have been better, but it wasn't ending up being better. Does that make sense? Yeah. So it eventually ran out of the science, and I just sort of said, oh well, that's it. So here's that little green dot is me. In the end, so it wasn't a fiercely competitive competition. Like 35 people were in it.
So this call everyone, right?
This is everyone's, so it's the the leaderboard score, the mean log loss.
We got this view, so
Yes.
it's like what will be the student, what will be people higher.
Yes. Yeah, for sure. There's still plenty of people higher. So this was the public leaderboard. So I think it was like 15. Yeah, 15. So when the competition finished, the luck has it that I got bumped up on the private leaderboard to 7th.
Okay.
So super duper lucky. I think there was only a few people who were luckier than me in how much they bumped up. Oh, yep.
Like, for example, you get to know the other models that are better than yours. What sort of technology they're using? Were they using DFAT? What were they doing actually?
I didn't track down any of the other competitors except for the 3rd place winner. Yeah, I'll tell you a bit about him. Poor Alexei. Anyway, so after this happened and I was 7th place, like I think I've got a timeline slide a bit further down, but a few weeks passed and I got an email, and the email said like, we have a position left for this contest. Please let us know if you'd like to submit a report and code for evaluation. It was like really sudden. The confirmation is expected by tomorrow morning. But I had a moral dilemma because my best performing submission for the leaderboard, I was unable to reproduce it. And so I had the choice of submitting my code and being found out that it doesn't actually produce the result that we saw in the leaderboard, or just what the hell, just do it. And so I decided to just do it. So I think, so I said, yes, I'll do it. I'll submit my code. It was like, can you share your model code properly commented by today? After reviewing the model code, we will ask you to share your report with us. So just scrambled to piece it together. Like I had to move it from a whole bunch of different sheets, scripts into a single script for them to run, and on their holdout data set. And somehow they managed to get it working. There's lots of back and forth. It did work apparently. It didn't error out. So it worked on unseen data. So, well, maybe they just said that. I don't know. But anyway, so yeah, so this is sort of the timeline. So I ended up submitting that report on the 27th of March. And then on the 7th of April, I got that email that you saw at the very start where they said I came 2nd. And there was 2.5 months before they actually got around to paying me, which I didn't think they would because they haven't made any competitions since. And they've sort of pivoted into offering a little known service called AI consulting. Have you heard of it? You know. Anyway, so I don't know. They turned into vapor, but I was lucky because I cashed out. So this is another cool ggplot chart I made of my how it went like that. The higher ranks in the private, you know, so why didn't one or two submit their code? Maybe they were disqualified because some people made fake accounts to get more than 5 submissions a day. Maybe unlike like me, they just couldn't reproduce their results. Yeah, maybe they, you know, I like to think I didn't make that mistake, and you know, I'm a pretty honest guy. I didn't use future data, and I was very deliberate in not using it, but maybe they did. You know. Anyway, so all those people above me, got a chance, but they didn't, and then somehow I leapfrogged number 5, whose report must have been poor or something. Anyway. Also, I've got a mate out there, James Northrop, who really helped me put the report together in like one day because we had to, you know, we had that email, I had to smash out the report. So we made a report in one day, and that was invaluable. I probably owe him some cash, but anyway. All right, so what did I learn from the experience? Informational advantage is a great motivator. If you think there's some sort of killer edge that you've got, it's, you know, obviously that's the best thing. When doing ML, track all your submissions. So now I definitely save, you know, in my professional, the few predictive modeling that I do, I save the functions so I can recreate submissions basically. Another takeout is to back yourself even when you risk embarrassment. Give it a shot. The positional changes from public to private leaderboard are largely luck. Don't overfit your cross-validation. Don't overfit your model to the public leaderboard. Fit it to the cross-validation metric. Maybe that's the takeaway. And yeah, make nice, you know, functional ggplot charts for the report to illustrate what you've done. Because decision makers need like something to point to that shows your exceptional skills. This is the code repo. It's just, you know, attach analytics, and then you'll see the repo, the hackathon. It's got the script I used to submit and the data. That's it. I think that's it. That's the end of my talk.